Okay, on previous videos that I did, I showed how to rebuild one of these KZ1000 rear master cylinders. I did mention that I was going to do a follow-up video on how to re-sleeve one if the bore is damaged. Now this one, which it's gonna be kind of hard to see from the video, if we can see that, there is pits in the bore that go in deeper than what I want to open the bore up for new seals. So we can't reuse this without putting a sleeve in it. So the sleeve we're going to use, this is one I had pre-cut already. This is 17 millimeter OD by 0.5 millimeter wall thickness 304 stainless steel tube. So when I buy the tubing, it's in a full length like this. It's about 12 inches long. Now, the tools that we're going to need to do this job, one of them in particular is going to be my milling machine, which obviously I don't have sitting on the table. But the basic tools that you're going to require in addition to that, this is a 0.688 reamer, or 0.668 reamer. This ends up being almost size on size with the OD of this tubing. Now when you buy these new, now this one is already honed, you have to take a honing stone and kind of break the edge on the reamer so that it'll actually cut the size. If you try to run these when they're brand new out of the box without honing the edge, you're going to find that it cuts about 2/1000 oversized, and that will mess up your part because that'll be too big to be an interference fit for this tubing. The other tools I have up here, I have this is a 5/8 reamer, and I don't use this to actually ream the part out. I use it to line up the bore. The original bore on these was pretty much 5/8 of an inch plus or minus a thou. So this fits really nicely in here. You got just a little tiny bit of play. But what I'm going to do is when I fixture this in my machine, I'm going to mount this in my spindle, bring my part up in there, and then clamp my part in place so I'm lined up on center line with my spindle. Put that guy away. Other tools that you're going to need, obviously calipers, hammer. I have this is my mounting fixture that I use for mounting the master cylinder into my vise in my milling machine. So it basically lines up bolted through bolts on here. The ones that are threaded, I actually just have metric bolts that'll put in there, and it lines it up. The other tools I have is a hand drill with a number 31 drill bit. That's going to be required to drill the larger hole through after we re-sleeve this. I've got another just rotary tool with a micro bit, and these micro bits I just get from Harbor Freight. There's nothing special to them, but the bit size that I'm using on this is about 25 thousandths. This is for putting the small hole that's in the middle of here back through the tubing. Other parts you're going to need, this is a 800 grit 16 millimeter hone. I use this for polishing the tube after it's inserted. If you Okay, I had reset the video because my air compressor was running in the background. It was very noisy. So getting back to the tubing, when I buy this tubing, the outside of it is usually got a very nice finish and is very consistently measures out to 17 millimeter. The ID, however, is a different story. The inside of the tubing is still basically mill finish, and there is an electro weld seam inside of it that is kind of rough, and it has striations that go parallel to the tube. So after we install this tube, we have the press fit into the master cylinder, we need to go back with the hone and polish this bore to get rid of those imperfections, those surface imperfections, so it'll seal correctly. And the the bead hone also takes out any burrs that are left over from drilling the cross holes. So other tools that we're going to need is, this is my, what I call my cutting mandrel. And this piece I have turned and honed on the outside, or turned and polished on the outside to be about a 1/1000 slip fit on this tubing. And I've made a mark that's just a little under 50 millimeters in. I need to cut this tube to 50 millimeters long. So what I'll typically do when I cut this on my lathe is I will make a mark on the new tube at 50 millimeters, and then I'll bring this around my mandrel, and then when I put it on my lathe chuck, I grab it so that about a ½ an inch of this is poking out the end of the mandrel, or poking out the end of the chuck. And in that way my vice jaws clamp down in the tube, and then this mandrel will support the tube so I'm not distorting the shape of it. The other tool that I made for this project, this is my insertion mandrel. So this is turned on the end to be probably about a 5/1000 slip fit. It's definitely smaller than this guy is. So it fits pretty easily. This is what I'm going to use once I bore my master cylinder out and I'm ready to insert it. I'm going to put this in, and then if I have to tap this with a hammer, say it stops, even though I'm going to freeze this and I'm going to heat this, if I have any interference, it gives me something to push on where I'm not damaging the end of the tube. So obviously I had to make these two tools, and I had to make this tool for this project. So other thing you're going to need is a deburring tool. You're going to need that when you get around to, when it gets to the point of starting to cut this tubing. There's always a burr from where they cut it, and you have to take that burr out before you can put it around the mandrel. Now, just for a little background on what exactly we're doing and the measurements that are involved, here's kind of a sketch of the piston assembly and then the barrel cut away on the master cylinder. So our sleeve does not need to go all the way to the bottom of this. We only need to go in about 2 millimeters past where the seal would end up in here. So where the end of my, once this is inserted and bottomed out, this would be like my piston, the first rubber seal, the second rubber seal, and then normally the spring would be back here. It actually ends up being about 48 millimeters. So what I do is I'll actually cut my tube at 50 millimeters long, so that gives me like a 2 millimeter extension past the cup. Now my overall dimensions, I have a 24 millimeter step from this face to here, and then plus my 50 millimeters, so I'm at 24 millimeters, or 74 millimeters total. So that, when I get around to reaming this and I set my tools up, I'm going to touch my reamer off from the top of here, and then I know that if I go past 74 millimeters or slightly past it, that my tube will bottom out at the right position in my barrel. Now, these reamers don't cut square on the end. There is a small bevel, which is your lead-in on the end. Now that bevel only goes down about 1 millimeter. So when I cut this, I want my tube to be 50 millimeters, and then I'm going to cut 1 millimeter past that. So I'm going to cut down to 51 millimeters on my machine before I insert the tube. All right. Only other thing you're going to need, brake clean, obviously hammer, drill, and we'll get to the milling machine and lathe here shortly. This is probably not something most people would have the capability of doing in their garage. I'm kind of lucky that I actually have the machines available to do this. And if you've got friends or somebody that has a milling machine and a lathe, I mean, by all means, it's not a very technical challenge to do it. You just have to methodically follow procedure when you do it. So, well, right now that's the discussion on this, and we're going to go over to the lathe, and I'm going to show, starting how we cut these tubes. Okay, so we're going to get ready to cut this tube. Now, this is a piece that I've already cut 2 other ones off of, and I'm just going to continue to use it. So after I cut it, it rolls a burr onto the inside. So if I were to try to put this mandrel on right now, it would actually scrape this mandrel up pretty good because it's not going to fit. So I'm using a small router burr, and very carefully deburring the inside of this. Now you want to double check, make sure there's no burrs rolled in on it. And then that mandrel should be able to fit pretty easily, which it does. So there must be some small burr on the inside because it is scraping it a little bit, but that's not that bad. So now I want to make a mark on my tube on where I want to cut it. So we know we want to cut it to 50 millimeters. So I'm just going to set my calipers at 50 millimeters. Sit down here. Okay. So I know approximately where that is. I'm going to take a Sharpie and just sort of booger this up a little bit here. You can use machinist die on here too if you want. I just prefer Sharpie, it's right there. And then I'm just going to scratch a little line at 50 millimeters. So now that's my cut line. So I'm going to insert my mandrel. If you notice, I've got a mark on the mandrel right here. So that mark ends up, when it's on here, ends up being about 2 millimeters behind that line, which is what I want, because when I cut this off, I don't want to cut into my mandrel. So we're going to just get our mandrel in there, lined up with the line, and now we're ready to go over to the lathe. Okay, so we've got our part ready to go. This is my Logan lathe. It's just a small 20-inch lathe between centers. The little Harbor Freight lathes work fine for this too, because it's really not that big of a part. So what I'm going to do here is I'm going to install this into my chuck, and like I said, I want this line to be about 1/2 inch out of the chuck. So that gives me my work area. And I'm not going to I'm going to snug this down, but I'm not going to go crazy on the tension because I don't want to distort the end of that tube. And that's the reason too I got the mandrels, to keep this relatively solid. So the tool I'm going to use is just a small parting tool. I think this one is 93 thousandths wide. And put the guy in. So manually rotate it. I'm going to bring this up to my line that I had previously made. And right there, that's where we're going to cut. So I'm going to start my lathe up. And right now I'm spinning about 1,000 RPMs. I actually want to spin slower than that, so I'm going to turn down the VFD. I want to be at about 500 RPMs. Pretty good number. Stainless steel, you got to be kind of careful. You can overheat it and work harden it pretty quickly. So I'm just manually feeding this in, and I'm taking a very light cut. I'm trying not to put too much force on here because I don't want to roll the end of this in any more than I have to. There we go. That cuts that off. So the piece I want to save is still in the lathe. So what I'm going to do next is just deburr that a little bit. So I'm going to start this guy back up again, and I'm going to max the speed out. I'm running about 1,000 RPMs, and I've got some emery cloth. So I want to very carefully emery cloth this off. And if you notice, my arm is sitting on top of here, so I'm not like dangling myself into the chuck. I always want to, if you're going to manually polish something on a lathe, make sure you're braced so that you can't get stuck in something that's spinning. So I'm just going to carefully polish the outside, and I'm going to roll this kind of inside here. And I'm just going to kind of polish up the bore a little bit. So that's pretty nice. You want it so that, like, if you run your fingernail down the edge, you don't want to be able to catch an edge on it. All right, so now that our tube is cut, we're going to pull it out. Pull it off of our mandrel and we'll inspect it. Now you see it rolled a pretty good burr on the inside of that tube. So that goes back to, well, you're going to just use our router burr again, which I have over here. And that is just, I'm just going to carefully take the burr out. Now, if anybody, you ever used one of these, any of the old machinists will tell you this is probably the most dangerous tool in the shop. Because if I were to slip off, I'd cut myself pretty deep. Normally I wear gloves, but I've done this enough that I feel comfortable with. So whenever you're using one of these, I'm putting very light pressure on here. I'm not like pulling way hard, because if that snaps off, obviously I would get cut. So that's going to go on both sides. Okay. So now the opposite side from where I started has a little bit of a burr on it yet. So I'm going to go back on the lathe again, and I am going to just polish the outside of that with emery cloth. I'm going to hang it out a little farther this time, because I don't need to be as close to my chuck. Yeah, that's nice. Perfect. All right. So I'm going to shut the lathe off because I don't need it on anymore. And that is a complete tube ready to go. Okay. All right, so we're going to get our mill going. So I'm going to travel over here. So this is my milling machine, and it's an old Tree Journeyman 325 that I retrofitted a K-flop CNC control onto years ago. It originally had a Dynapath control, and the controller was dead, so I did this conversion. If anybody wants to know, I could possibly do a video on this at some point in time. I use this machine a lot, and it's actually been a really great machine. So what we have here is I've got my vise, and then I have my fixture with my master cylinder on it. Now, when I made this fixture, I milled this bottom square, then I came back in and put these two holes in line. Now, originally, I thought that that was going to be good enough if I push this up to keep this straight. Come to find out that these all have a little bit of a variance to them. So I opened the holes up a little bit to give it a little bit more play. And then what we're going to do is we're actually going to loosen the vise up too. We're going to get this thing in position so that this reamer is inside of it and it's centered, and then we're going to tighten everything down and then back it back out. That way it stays centered. I'm sure somebody's going to say something about it, saying that's not the right way to do it or whatever, but to be honest with you, trying to get this thing straight and lined up, I've done it with a dial indicator. It takes forever to get this straight, and it's still never perfect. This seems to get it good enough that I've never had an issue. So for starters, what I'm going to do here is I'm going to just snug my fixture down a little bit, pull my clamps out of the way. I'm going to loosen my vise up. Now, this vise does not have keys in it. So once I loosen this, I can actually move this vise around a little bit, which I want. So I'm going to actually kind of try to find the middle of my extents so that I got a little bit of wiggle room here. And then I'm going to jog my machine over. So I'm kind of close to being centered. And I'm going to bring my Z down into the part. Now, I'm loose enough right now, if this were to hit, it's just going to kind of move around. So, actually, before I even do that, I'm going to bring this up to the top of my part, and I'm going to zero my Z, so I know I'm not bottoming out. So we did that measurement before, and I know that from here down 75 millimeters, I'll be clear, and I'll actually end up with like 10 millimeters still on the bottom. So I can actually use that measurement if I convert it. 79.4 is like 2.9552. So I'm going to bring my Z-axis down. And now I can feel it actually engage the part. So I'm going to kind of wiggle it around a little bit here. And I'm watching my indicator. And I'm going to take it down to the 2.95. So I'm at pretty close to the base and where my bore is still the smallest. So I did hone this out a little bit before, trying to get the pockets out, but I couldn't. So it is a bit undersized. So now I got it's lined up, and you notice, like, if I move it side to side, I only got probably 5 thousandths at the most, maybe 3 of play. So it's pretty well centered. So now I'm just going to gently tighten down my vise, and then I'm going to tighten down the bolts that hold my master cylinder into the fixture. And I usually just kind of tighten them, just snug them just a little bit, and then make sure they're all snug, and then come back and really torque them down. That way it doesn't start moving your part around. Sometimes if you torque one screw like too much at a time, it'll shift your part. So, all right, so now we are lined up with the machine, and I'm going to zero my X and Y axis. So now I'm zeroed with that part, and I'm going to retract Z. Now this is a CNC mill. However, I am not going to run a program to do this. I'm going to manually run the reamer down. So this is obviously, we got to change this reamer out. Now this is a 9/16 shank on here, and my other reamer is also 9/16 shank, so I'm going to use the same tool holder. So I'm going to unlock my tool, pull it out, go over here. Set that guy off the side. Here is my 668 reamer, and I'm going to go in, I don't know, about 1.5 inches. That's about where I was before. Tighten it down good, and we're good to go. Now, I need to touch this tool off on the top of this part. So what I'm going to use, I'm actually just going to use a rock drawer. I'm going to use a parallel. So this parallel is about 298, 300 thousandths thick. So I'm going to use that, and I'm going to use a piece of paper. So I'll set my calipers over there. I'm going to set this across the top. And I am going to gently jog my tool down with a piece of paper underneath it. Now, when I get close, which I'm getting pretty close right now, I'm going to back my feed rate off so it's 1/10 of a thousandth per click on my dial. And then I'm just going to slowly bring the dial down while I move the piece of paper. There we go. And wait till it grabs the paper. So now what I'm going to do is I'm going to just zero my Z-axis again. I'm going to bring it up so I can pull my part out. And then we're going to measure what our difference is here. 301. Set that over there. And we are going to move this down to 0.301. Oh, I passed it. Zero. Okay, so now the top, our reamer is level with the top of this. So now we know that 74 millimeters from that edge to the bottom is where I need my tube, and I want to go another millimeter past it so I have a little bit of leeway for the lead in of the reamer. So I'm going to go in a full 75 millimeters. So 75 millimeters converted to inches. So I'm just going to take 75 divided by 25.4, 2.9527. So that's what I have here. So I calculated our speed, our RPM should be about 300 RPMs, which is roughly 55 to 60 SFM. And we're going to feed this at about 12 thousandths per revolution, which comes out to be about 3.66 IPM, inches per minute. Now, I'm going to feed it by hand. Now, if you notice on this dial, when I move this, my feet per minute indicator can go up. So I can maintain that 3.6 if I want to. And that's what I'm going to do. I'm not just going to manually feed this because I want to have the ability to just back it off if I want to. So we're going to start by starting our spindle at 300 RPMs, which this is a PC-based control. So I'm going to enter this at the bottom. So I'm going to go S300 M03. So now my spindle is running, and I can turn it off and on now at that RPM if I want to, right on the screen. So I'm going to add a little bit of this foamy cutting fluid. This stuff works pretty good. I use this for tapping too. Just put a little bit of juice in there. So it needs some lubrication. Now, I don't want to take this reamer all the way down to the bottom because it's going to plug up with chips by the time I get through there. So what I'm going to do is I'm going to come in about an inch into the parent material. I'm going to back it off, and then I'm going to do a final cut to take it to final depth. So I'm going to split this into two passes. So my first pass, see, I'm going 2.9, so 24 millimeters is about an inch. 50 millimeters is just a hair under 2 inches. So my first insert into here, I'm going to go 2 inches in. I'm going to back it out. I'm going to blow everything out and clean it, and then I'm going to relubricate it, and I'm going to bottom it out to the 75 millimeters of the 2.952. So I've got my feed rate right now with my hand wheel at 1 thou per click. So I'm going to watch my indicator as this goes down. And you can see my load came up a little bit, and I'm just going to keep feeding. I'm kind of listening. If I hear this thing starting to squeal, I need to back it off like right away. So I hit 2 inches. So now I'm pulling it back out. Okay, I'm going to grab my blowgun. And that cleans all the flutes out on my reamer, so I'm ready to do another pass. Give it another squirt, and now I'm going to go to my final depth. So I can feed pretty fast now until I hit the 2-inch mark, and then I'm going to feed back at the same feed rate until I hit the 2.952 mark. I'm watching. As soon as I get close to that, now I gotta slow it down. So now I'm trying to hit my 2.952. All right, so I hit it. So I'm gonna speed that up coming out. And I'm gonna shut off my spindle. Now see how this chips build up in those flutes. If I would have just kept going, that would have completely blinded my reamer and possibly seized it into my part, which obviously would be bad. It would destroy my reamer and it would destroy the part. So now we're going to take this back off. All right, and I'm going to initially just blow it out. Okay. And I am going to go and I'm going to hit it with some brake clean. And I've got a bucket over here to kind of catch it in so it's not just going all over my floor. But that cutting oil, for some reason, doesn't come out very good in the ultrasonic cleaner. I don't know why. It's whatever its chemical composition is. So I want to get this thing pretty clean. You can see how dirty that stuff is coming out of it. And then from there, I am going to give it about 15-minute round in my ultrasonic cleaner. Just to get any remaining chips and stuff out of there. And I also want to get any oils that are remaining in here off, because it's really imperative that that surface be ultra clean before you put in the sleeve. So I'm going to start this at 20 minutes and then we're going to come back to it. All right, the original video I had of putting this sleeve in got corrupted, so I'm redoing. This is a redo of how to insert the sleeve. It's a different master cylinder. This one actually has threaded holes in it. So I started out by kind of preheating this a little bit here, so because it takes about 10 minutes to do it, so I didn't want to have to videotape the whole thing. So right now I'm at about 160 degrees or so. I have the sleeve and the insertion tool in my freezer right now on the other side of the shop, and that's been freezing for a couple hours. My freezer is set to, it's like -9 degrees it maintains in there, at least according to the thermometer. That's the range it's at. So what we're going to do is we're going to heat this up to around 200 degrees, 220, somewhere in that range, so it expands it. And then my sleeve, because it's in the freezer, is going to shrink. So then we have one that gets us close enough that hopefully my sleeve should insert pretty easily. I shouldn't have to force it too hard. If you try to do this without expanding and contracting the two, it takes a lot of force to get that sleeve in, and then you risk wrinkling it as you're inserting it. So I'm going to get this guy up to 220 degrees. I'm going to heat this guy up a little bit more. You want it pretty hot. I mean, a propane torch works really well. It's almost impossible to completely overheat it with a propane torch. If you're using MAP gas though, or if you're using oxyacetylene, you got to be careful not to melt the aluminum. But it doesn't really give you any warning before it does. So I'm just gonna heat a little and I'm gonna check it, and then okay, so we're actually pretty close. I'm gonna give it just a little bit more heat. These things take a while to absorb the heat because it acts almost like a heat sink. It sucks it into the bigger portions of the aluminum. So it might have it up to temp, but it only stays there for a few seconds. So you really want to make sure the whole thing is kind of heated up. See how much cooler it is at the bottom, because that's just sucking up all my heat. We're almost there. That's pretty good. All right, so I'm gonna grab my sleeve. Want to kind of be quick here. And I freeze the insertion tool in there too, so everything stays cold, and that way it stays colder longer. So we're gonna be quick about this. Put it in. And you want to get it all the way home. Just about there. There we go. So I don't know if you can see this. I will try to get a better view here. You can see that the top of that sleeve is now even with the top edge of the aluminum, which is right where we want it. So now I have to wait and just let this cool down. It probably takes about 30-40 minutes. You want it to just cool down in the natural air. Don't force cool it with water or anything, because you might end up cracking your cylinder. Okay, so we've let this cool. It's been actually a couple hours. I had other stuff to do, so now we're back down to room temperature. So now what we have to do here is we have to chamfer the inlet so that the seal can pass through correctly. Originally there was about a 1 millimeter 45-degree chamfer on that, so we're gonna do that by hand with the Shaviv tool. And there's two holes that need to be drilled. One is drilled through on an angle, and that is approximately, I usually use a number 30 drill to drill that on an angle. And then there's another tiny hole that's about 25 to 30 thousandths of an inch that's drilled straight through that. So we got to drill through our liner because right now there's no fluid inlet. Now this angled hole, I've done it before using just a hand drill and going through there, but you got to be super careful because when the drill bit hits that sleeve, it's hitting it on an angle. So it tries to walk and actually like wallow out the hole. So I found the best way to actually do this is on a drill press instead of trying to do it with a hand drill. I mean, you can do it with a hand drill, but it never comes out perfect, but it'll still be functional. So I'll go over here to my drill press and I preset this up so that it takes a little while to do this setup. I set my table at a 35-degree angle. I don't know if you can see that, which is the angle that this hole comes in. So I've got my drill already set up in here. So I'm going to bring my fixture in, and I'm just going to before I tighten it down, I'm going to just get my drill lined up on there, and then I'm going to tighten my vise down. I've just got this held down by vice grips right now because there's no good hole to really hold it down from, and I'm not using a lot of force. So the drill press on, light on, and then we just carefully okay, I'm going to tighten my drill bit up a little bit more because it ended up shifting. I don't think I had it very tight before. You got to be super careful because that thing is going to try to grab that drill bit. Now I can hear it right now, it's making contact with the stainless steel. Okay, I'm through. All right, so now I've popped the hole through. You do want to set, if you want to, you can set a stop or something on it so you can't accidentally go through, because if you hit the other side and you leave a dent in that tube, then the whole thing is toast and you got to start all over again and pull that tube out. So I'm going to, actually I'm just going to leave the drill in here. Let's just pull our part back out. And yep, we have a nice hole through there. Shut my light off. We're going to come back over here. So now if I flash a light through here, you can see that there is a hole going through. So now we have to drill a small hole, and I'm just going to do that with my little Harbor Freight drill bit set. So this drill, I believe, is around 25 thousandths. So I'm just using this cheap little rotary tool. Right now it's spinning 1,000 RPMs. I'm going to actually spin it up to 1,600. You got to be really careful with this. Make sure that you're going through straight. And I'm just putting real light pressure on it. I'll just hold it on there for a second or two and then I'll back it off. Now your wall thickness of your tube is almost the same as the diameter of this drill, so it actually takes a little bit here to get through this. You will just want to be patient and not press too hard. If you press too hard, it will snap the drill bit off. And I'm just going I'm going to actually look at that because it seems like something is... No, it's drilling through it. I'm just not quite through yet. You don't want to sit in one place too long with it. It will overheat. All right, so I had to switch drills because that other one was getting really dull. It wasn't making it through. So we're going to try this again. Same thing, I'm set at about 1600 RPMs. There we go. Oop. Yeah, and it broke it off. So let's take a look here. This is by far the hardest part of it, is trying to get this little tiny hole drilled, and I'm sure there's probably better bits than this. In fact, I'm positive there is. I just don't have any here at the time. So we're gonna pop that broken one out, and I'm gonna put this guy in here. And I'm gonna at least see if I can poke the other one through. There we go. So all the way through. Shut my drill off. And there's my little bit that came out of there. All right, so now we have our holes. If I flash my light in here, you should be able to see light through that hole. There's a little bit of debris in there. There we go. Now we can see it. So next thing I'm going to do is I'm going to chamfer this bore on here. So I'm actually going to put this back in my vise. And I'm going to turn it horizontally here. So for me, that just makes it easier. Now, I did grind the outside of this. I had to take about 10 thousandths off the OD diameter to make a nice fit in here. This is just a plain Jane hand deburring tool. I like this because this one stays nice and sharp. So you got to make sure that you enter this relatively level and straight. And there we go. I'm just putting light pressure on it. And you can do this with a drill too. Or if you've got just a regular 45-degree countersink, as long as it will fit in this hole is the key. So I'm not taking a whole lot of material off. It really only takes like maybe 5 or 6 good rotations. I mean, see, it puts a nice chamfer on that edge. So you want to chamfer it all the way to the outside edge of your tube and then a little bit into the aluminum. So you get about a 1 millimeter chamfer on there. So now that we've got that, sleeve is in, sleeve is drilled. Now we just got to deburr the sleeve and do any polishing. The tubing that I'm using right now is electroweld. I do have some other tubing that I've used, but I don't have it in stock that's seamless. The seamless tubing works better, but it's hard to get. It's very expensive. But the electroweld works too. It's just you end up with this seam on the inside that you have to polish out. So I'm going to start out initially. This is a 320 grit 16 millimeter ball hone, and I'm going to grab a little bit of oil. And I'm just going to give a quick little squirt. And then we're going to hone this guy out. And this will initially, should take most of the burrs off of the inside of those holes. And the stainless steel takes a long time to wear through, so don't be afraid to polish on this quite a bit. Okay, so now we're gonna do here is I'm just gonna stuff a wad of paper towel down there and kind of clean the debris out. And I'm pushing it in with a screwdriver, but I'm trying not to hit the walls. Actually, I balled that one up a little too much. You want it to kind of ball up in the bottom, so when you pull it out, it kind of cleans it. And I'll grab a flashlight here, and we'll take a look down it. Now, just looking at it, that, I don't know if you can see that on the video. I'm going to try to get this on an angle where you can see it. That 20 seconds or so with the hone was enough to get all the burrs off of the holes. And as I kind of work my way around, you can see at one spot there's a line that runs parallel to the tube, and that is my seam. So it's definitely a deviation from the rest of the surface finish. So the next stage here is I need to get that seam polished back to the point where it's pretty much non-existent. Because what'll happen is that it causes a minor indent in your radius, and that's where you're going to get a leak. It might not be enough that the cylinder doesn't function, but it's probably going to be enough that when the thing sits, you're going to see it's going to start to drip out of the bottom of the main seal, or the secondary seal. So what I'm going to do is I'm going to change out my hone, because that 320 grit, if I tried to hone all that material out with 320 grit, I would be there for a month. So I have a 80 grit, 180 grit. So we're going to go to these other two grit sizes. Now 80 grit, this is really aggressive. So if you're going to use this, like if you've got a deep seam like this has, I only want to give it maybe 5 or 6 strokes with the drill. Pull apart, clean it, check it, and then keep coming out. You can easily end up taking your cylinder out of spec with this. But we're going to do the same thing. Put a little bit of cutting oil in there. And then, like I said, I'm going to give it about 5 good strokes, and then we're going to check it. Now, a lot of times, the other thing too, because of the aggressiveness of here, you want to kind of get it started a little bit and then start it spinning when you enter it. So that's 5. So now I'm gonna clean my bore out again. And I keep putting too much wadding in there. And if this gets stuck in there, which once your paper towel gets wore out, you can always blow air into the top and it'll pop it right out. So now it was 5 strokes in there. So now I'm going to look at it again, and I'm going to try to find my seam, and it's still there. There it is. It's on this lower edge. So I'm going to do this again. I'm going to do another 5 strokes. And maybe I'll go 8 this time. I'll go with a few more. But all right, so our seam is now gone. I don't see any signs of it anymore in here. Just like a little, maybe a haze, but I think that should be fine. So now we're going to switch grits. So I'm going to lose the 80 grit. And I'm going to go to a 180 grit. So we're going to take this down with a 180 grit and get all the 80 grit scratches out. And then we're going to go to the 320 again and get all the 180 grit scratches out. Same thing, I'm going to put a little bit of oil on there. I really like this fixture because you can get a good grip on it. Now, I went quite a ways with that. This doesn't do a lot of hard cutting, but you kind of want to get that surface burnished a little bit. Okay, let's pull this. Okay. All right, let's see what our finish looks like. Oh yeah, that looks fantastic. Okay, so that was another 30 seconds with that 180. I'm gonna put this away. I always make sure I put my hones away right away. There's color codes on them that tell you what grit they are, but eventually that color code tag gets kind of wore off. So that way at least I don't have to guess at what grit I'm going to. So here's my 320 grit. This is my final. So we're going to do about another 30 seconds with this one. And let's take a look here. I'm going to grab a new piece of paper towel. And we're going to take another look here. And that looks great. So the final check, I'm going to check it with my bore gauge. The bore gauge is set to 0.625, so I actually want to be a little bit bigger than that because I want to be about 16 millimeters, my goal. And I am right there. Maybe, depending on where I'm at, I'm about maybe a thou over. Towards the bottom, I'm about a thou under, which is actually perfectly fine for what we're doing. Okay, and that is pretty much it. So now, like the other video that I made, we go through and just put a whole new piston, seals, and other kit containing, kit components in it. I'm going to run it one more time through the ultrasonic cleaner to get all this gray schmooze out of here that's from the polishing and the honing operation. I don't want any of that left over in there. Plus this cutting oil too is not compatible with brake fluid, so you don't want any of that remaining inside your master cylinder. So basically, first thing I'm going to do is hit it with brake clean again, like we did in previous sections of the video. Get as much of that out, and then it's going to go in the ultrasonic cleaner, and when it comes out of that, I'll dry it, and then it'll get reassembled. So that is the procedure that I follow for adding in a stainless steel sleeve on a KZ1000 rear master cylinder. This is also applicable to, this is from a KZ750. This has the same bore size in it. And it literally bolts up to the same fixture, so the process is the same. For a KZ650, the cylinder looks identical to this, except for it's a 14 millimeter and not a 5/8. So the KZ650 is the same procedure, but you're going to use a different size reamer. I'll use a 14 millimeter reamer to start it in the machine, and then I'll bore it out to a 15 millimeter size, and then I have 15 millimeter OD by half a millimeter wall thickness tubing that I would press into it. So there's a different set of tools for doing the smaller cylinders. The other option though with the 14 millimeter cylinders was, depending on what the customer wants, you can actually take the 14 millimeter cylinders and just run a reamer through it, open it up, and then re-hone it to 16 millimeters or 5/8, and just put the 5/8 innards in it, just like a KZ1000, and it'll work just as well. It just won't have build as much pressure as the 14 millimeter cylinder did. But all right, I hope this helps out, but this kind of describes my process, and like I said, like it, share it, go on the website if you want to buy. We have rebuilt master cylinders, and I also do this as a service. So thank you.